Okay, on to section 1.2 about input-output. So we've already seen a little bit of output because we've been using printf. The input function, which will be somewhat similar, is called scanf. These both come from the stdio library, and so to use either of them, you have to include it at the top of the C source file, as we've seen, I think, briefly somewhere else. So let's write some notes here. When you are typing a string literal, and this can be in Python or C, it will typically not understand line breaks, tabs, and certain other special characters. So if you want the string to have a, something like that, if you want it to have a tab, then you have to type /t, and that, the computer will understand that wherever there is a /t, it essentially replaces it in a sense with a tab. And for line breaks, it's /n. And we've already seen percent followed by a letter is used for format strings as a placeholder that will be substituted by, in the case of %d in Python, and I guess in fact also in C, %d is replaced by an integer. So that leaves me wondering what %lu was from the previous video, but honestly I just don't care enough to go look it up. If I need it, I'll go look into it, but for now I'm fine just thinking that %d and %lu are somehow each substituted with some kinds of integers. Okay, anyway. So let's see how we use some of these things in Python and then in C. So here in Python, we're just going to have a main function. There's nothing else to this function because of how I moved this over from the textbook. The alignment is off, but let's not worry about it. These lines are indented inside of the main function. Right, so we have a format string here. It has a %s. %s is what you use for strings, and here you have a string. So, so what this is going to do is take the string and insert it into that position in the format string, and then print the result. Here we have an instance of two different placeholders, and it always substitutes them in sequence. So %d holds a decimal value, and so this decimal value 20 here is what's going to get inserted in %d. This is a tab character, right? So when it renders, when it prints to the screen, that will get replaced with a tab. And then 5.9 is a float, and %g is what gets replaced by floats. Here we have a tab, some text, a decimal, which is 3 in this particular example, and then a string, which is this one, Alice Paul. And so that's what you would see when you run this program. Okay, and of course, at the end, unindented is the call to the main function. So when you run this Python program, the main function gets called, and you see all of those things print. Okay, now let's see how it's done. Basically exactly the same output, this time accomplished in a C program. Okay, int main as always. And of course we do need to include the standard IO so that we can use printf. We have a format string with %s and another string literal, so that works very similarly, right? You can contrast the syntax here. Here Python uses a %sign after a format string, whereas in C, this is all handled by the printf function, right? These are basically multiple arguments to the printf function, but these are just a few sort of, at least for now, pretty minor seeming differences between C and Python. Okay, %d takes a decimal, and %g takes a float. %d, %f, there's a decimal, there's a float, or a string. Okay, so as always, return 0 at the end of your main function. And the end, right? And as always, no need after defining the main function to make an explicit call to the main function in C. Okay. Both of these will print exactly the same thing. Yeah, and I guess we could also emphasize that when programming in Python, if you want a line break, then you have to include /n inside your format string. Okay. %g is for floats, %d is for decimal values, which includes these things. S is for strings. %c is for chars. You can see an example here, I think. Well, yeah, you can. Okay. Okay, so that's printing. Let's move on to scanning, which is input. Now, keep in mind that the way that scanning is supposed to work is it's supposed to gather input from the user after the program has been initiated. So, basically, when you use scanf, you will write it in your source code. You will, let's talk about C. So you're going to compile it to bytecode, and then you're going to run the bytecode. And when you run the bytecode, then wherever it hits, your call to scanf, it's going to stop the program, and in the terminal, have a little probably blinking cursor and expect the user to type some stuff. It would be good to demonstrate this in practice, and we'll do that when we get to the homeworks, but basically just know that using scanf means that you compile, you run, and then after you run, it will at some point expect you to type more stuff into the terminal, hit enter, and that's how the input gets into scanf. Okay. Let's look at demonstration in Python. So as usual, we have def main. And in Python, we don't use scanf, we use input, right? They're kind of the sort of analogs in Python and in C. So in Python, we use input. We give it a little message, right? So this message is going to get printed to the user in the terminal after they run the program. And then it's going to, right, it's basically going to pause the program and wait for the user to enter something into the terminal, and whatever they enter is going to get stored over here into this variable num1. Now, a fairly important thing in Python using input is that Python always interprets every input as a string. Well, if we want this to be a number, then after we read in the string, we need to turn the string into an int so that it then behaves the way that ints behave, right? If we wanted to add it to other numbers or do whatever we want to do with this int, we have to turn it from a string to an int. So that's what this line does. Okay, enter another number, and again, convert that string, right? Because enter a number, but Python understands it as a string, so we turn that string into an actual number. And then we can print these values, right? So decimal, 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 num1, num2, and their sum, right? And keep in mind that this sum can only be computed because they got turned into integer values, right? If they were still strings, then Python would be sort of adding these strings together. And in Python, what that means is concatenating the strings. But whatever, anyway, the point is this reads in two numbers and prints out the first number, the second number, and then their sum. Okay, and then at the very end, as always with Python, or at least when designing things this way, you end with a call to main. Okay, now let's see how all of that gets done in C. So as usual, use standard I/O. This time that's necessary not just for printf, but also for scanf. We make an int main function. We declare two integer variables, right? Maybe I might have wanted to reflect on that from before, but in Python you don't declare variables, right? You just throw data straight into the variable. And C is, for memory reasons that we will likely come to understand more later, wants to have finer grain control, and so you first have to declare the type, and then you can fill it with some value. Okay, anyway, moving along, we print a message to the user, right? So whereas Python kind of did it all in one line, right? Print a message to the user while also gathering the input that they will respond with. In C, those are broken up into two steps. Here is a print message to the user, and here is a command to pause and wait for the user to input something. Now this works a little bit differently. For one thing, we're going to put the value into the variable num1, but what we type here is ampersand num1. Why the ampersand? That basically means that we're talking about the address of the variable, right? The address in memory of the variable. If you don't understand what that means, let's not get into it right now. We will be studying precisely this, basically kind of the whole first half of the class, right? All about memory management and memory, allocating data to certain places in memory in your computer. But for whatever, whatever. Here we are basically just talking about the address of the variable. And here we are, using the format string %t, so that effectively what all of this does when put all together like this is it takes the input from the user, formats it as a decimal value, and stores the result into num1. Let's just say it stores the result into num1, which it does. So, okay. Then we do it all over again. Then we print the results. Notice that you don't have to change, right? Because it was, this here basically said that whatever the user inputs, we are going to basically parse it as a decimal number. So you don't have to do that step that we had to do in Python, where you had to read it in, but by default it's a string, and then you convert it to an int. You don't have to do that, or I guess you could say, in some sense, this is how you do that in C. So whatever. Anyway, now we have num1 and num2 both stored as integers. They have now been populated by these calls to scanf, if assuming the user has input whatever values they are. And so now we can print them out, right? Print num1, print num2, print their sum. As always with a C program, at the end of main, if everything went well, return 0. And so if the user had entered 30 and 67 in the terminal after running these programs, then this, or really the whole thing, is what they would see printed to the console after entering the numbers. Okay. What to talk about here? I think we basically already covered most of this stuff. Right. With C, what if we had different types, right? Int and float. And we wanted to input two things all at once, right? What we can do is we can make a single call to scanf and say that we want to interpret the first thing as a decimal and the second thing as a float. The results will get stored into the address of x and the address of pi, the two variables that were declared up above. The way that the user would input these values is that, they're basically on the terminal after they have run this program. And then what they would want to enter is something like 12 for the decimal, space, I'll put a little symbol like that to indicate that there's a space there, and then whatever 3.14 or something like that for the float value. And so by entering it into the terminal this way, the 12 is going to get put into the x, and the 3.14 is going to get put into the pi. If there were more other white space surrounding these things, it wouldn't make any difference.